In this lesson, we're going to look at how to solve an absolute value equation. So I want you to take a look at this equation. What could x be that would make the left side equal to the right side? Well, if we put a 9 here, 9 minus 2 is 7. Is there any other value for x that we could put here that when we take the absolute value of that, we would also get 7? And you might notice we could also have negative 5 minus 2 is negative 7. The absolute value of that would give us that positive 7. So in absolute value, we have two cases we have to consider. In the first case, kind of like what we did with piecewise functions, this in here can be positive. In the second case, we have to also consider if this in here is a negative expression, then we take the absolute value of that and end up with that positive 7. We can solve an absolute value equation graphically and algebraically. We're going to begin by taking a look at how to do it graphically. So the first thing we want to do is to isolate this absolute value piece. So I'm going to remove that negative 3 by adding 3 to both sides. That's going to give me now the absolute value of x minus 2 is equal to 7. I can then go ahead and graph each of these pieces. So I know that 7 is just going to be a horizontal line crossing the y-axis at 7. And then we also know how to now graph an absolute value piece. So this 7 is just my horizontal line there. And then in terms of this one, the original graph would have a y-intercept at negative 2. I can see it's linear. So I'm going to plot that at negative 2. Our slope is going to be 1. So I'm going up 1, over 1, up 1, over 1, up 1, over 1. I know that every point where y is positive or 0 is going to stay. Every part where y is negative is now going to reflect. The solutions, remember, are the points at which those two graphs intersect. We're looking at the x value. So I can see here, x is going to have a value of negative 5, and x is going to have a value of positive 9. And then let's also take a look at how we could do this on the graphing calculator. So I'm going to enter the one side as y1. So remember, we're going to go to math. We're going to go over to the number menu. Number 1 is absolute value, and we're going to go x minus 2, and then we're going to close out of there, and then I'm going to go enter, and we're going to put 7 for the second one. We're going to go graph that, and then we're going to go second function, trace. Number 5 is intersect, and then remember, you're only going to go left or right so that you don't go off the graph. You're going to move the first cursor so it's close, and then your calculator prompts you, are you on the first curve? Press enter. And if you watch that cursor, you're going to see it jump to the second one. So we're going to go enter, there it jumps, enter, do you want me to guess? Enter to say yes, and there you go. So we can see that y is 7, but it's that x coordinate we want. So x is negative 5, that's our first solution. And then we're going to go again, second function trace, we want number 5. So we're going to now go over to the second point. So we're going to just hold that right arrow down. The coordinates on the bottom of the screen are changing as that cursor moves. So we're going to get close. Are we on the first curve? Say yes. Second curve, say yes. Do you want me to guess what that value is? Say yes. And there is our second solution of 9. And then always make sure you verify. So if x is negative 5, substitute it back in. Negative 5 minus 2 is negative 7. The absolute value becomes positive 7 minus 3 is 4. So the left side equals the right side. 9 as x, 9 minus 2 is 7, minus 3 is 4, so both of those solutions work. Let's try another one. So in this particular one, I can see that I have a quadratic equation, and my absolute value is already isolated. I also have a linear equation on this side. So I can see that if this is a linear equation, my y-intercept is 4, so we can go ahead and plot that point, 4 right there is on the purple line. I can also see that I have a slope of negative 1/2 x. So that means I'm going to be going down 1 over 2, down 1 over 2, down 1 over 2, and that's going to be my first line. With this quadratic, I want to determine first of all where that parabola would lie just without the absolute value. So we need to get some key points here. I can go ahead and factor this to get my two x-intercepts, so we can plot those at 3 and negative 1. I'm going to then complete the square to get that vertex point. And I can complete the square very easily because I have an a value of 1. So I'm just going to take half of that x value, which is negative 1, and then I can see negative 1 squared is positive 1. I'm going to subtract 4 to get to that negative 3. So my vertex is going to be at 1, negative 4, which is going to be right here. I know that everything where y has a negative value is going to reflect over that x-axis, giving me this function for the absolute value graph of that quadratic. And then I can also see that I'm going to now have 4 points of intersection. Let's enter this as y1 and this is y2. This fraction, just watch, you're going to put that in brackets there. We're going to press graph. And there's the graph. So now we have to go second function, trace, number 5, And it's generally easier for most people if you work left to right. That way you won't miss anything. So there's our first point of intersection. We're going to go enter, enter, enter. So my first solution is -2. Then we're going to go again, second function trace, number 5. And you're just going to move that cursor until you get to the next point where those graphs cross, which is right there. Enter, enter, enter. There's our second solution at 0.5. Second function trace, number 5 again. We're sliding that cursor over. There's our next point of intersection. Enter, enter, enter. We didn't have to go very far that time. 2 is our next solution. Remember, it's always the x values. Slide the cursor over there first. And then second function trace number 5. Enter, enter, enter. And there is our last solution. So now you can go ahead and verify those just to make sure that the left side does equal the right side in each case. Algebraically is the second way that we can solve an equation, and it is the preferred method for most people. We begin the same way. So we're going to isolate that absolute value. So in this case, it's already isolated. And then we're going to solve two equations just like what we did when we set up the piecework. So we're going to start and say, okay, if this expression is positive, then we're going to have this side equal to this side. I'm going to subtract 3x to get all of the variables on one side, and then I'm going to also subtract 5 to isolate x, and that gives me my first solution. Now, it's really important that you check for extraneous roots. So we're going to substitute this back in. -3 times 3 is -9, plus 2 is -7. The absolute value is +7. If I put it in here, 4 times -3 is -12, plus 5, that's going to give me -7. That means that this solution is going to be extraneous, and I already knew that because if we take a look at this, when I take the absolute value of this side, I know I'm going to get a positive number. So that means that this side here also has to be positive. So x, in order for this to potentially work, has to be greater than or equal to that -5/4. This is going to give us a negative value on this side, which just won't be possible when we take the absolute value of that side. And now we're going to do the second case. So if this in here happens to be negative, we take the absolute value and it becomes positive. So we're going to check the negative case, and you can go ahead and distribute that negative in right away, flipping all of those signs. And then we're going to do the same thing. We're going to begin by moving our variables to one side. So I'm going to begin with the smallest coefficient, and then we're going to subtract 5 from each side, getting that to -7. We can divide out 7 on both sides, and our second solution we think is -1. But again, it's really important that we check. We're going to put it back into the original equation. So -1 times 3 is -3, plus 2 is -1. Take the absolute value, and we have +1 on the left. -1 times 4 is -4, plus 5 is +1. So in this case, the left side does equal the right side, so we know that our solution is going to be that -1. Just one note about the extraneous solutions. So we know that when we take the absolute value of something, we're going to get a positive number, or we can have 0. So we know that this side also has to be 0 or positive, but we can also consider the domain restriction on the piecewise function. So if we were to graph that function y equals 3x plus 2, we know we're going to get a graph like this. So I can find that x-intercept of -2/3, and we know that the original graph is positive for all values of x that are equal to -2/3 or greater than -2/3. We know that we're going to reflect that graph vertically about the x-axis for all values of the domain that are less than that -2/3. So in case 1, we know that x has to be greater than or equal to -2/3. -3 does not fit that condition. -3 is going to be down here, so we know that's not going to be a solution. In my second case, we know that x is going to be less than -2/3. -1 is less than -2/3, so that is a root that is going to be a solution to the equation. Always, you can substitute them back in, make sure the left side is equal to the right side. And we're going to take a look at one final example here. We happen to have a quadratic inside the absolute value. So I'm going to begin with my first case if this happens to be a positive expression. So we're going to write that down, and then we're going to have it equal to the other side. Now, because I have a quadratic, my goal is to get all of the terms to one side. So I can see that the x squared is positive. So I'm going to move everything over to the left-hand side and set the right-hand side equal to 0. When I go to subtract x, I'm going to subtract subtract x here, my x's are going to cancel out, and then I'm going to subtract 3 from this negative 2 to get negative 5, and then really important, make sure you remember equal to 0. Now to solve this, our goal is to isolate x. Normally we would either use the quadratic formula or factor this, but because we don't actually have an x term, we have an x squared term, it's going to be easier if I just begin by moving that 5 over. So I'm going to move that 5 over, and then in order to get rid of that squared on the x, I can square root both sides. And because I'm square rooting a variable, remember we're going to get both a positive and a negative square root of 5. Now in order to verify this, there's a few things we want to look at. So we know that when we take the absolute value of this piece, this also has to be positive or 0. So x is going to be greater than or equal to negative 3. Both of those values are going to be greater than or equal to negative 3. If we were to write this as a piecewise function, we can see that for this positive case here, which is that first one, x has to be less than or equal to negative 2, and the negative square root of 5 is about negative 2.23, so that is going to be less than negative 2, or x has to be greater than or equal to 1, and the positive square root of 5 is going to be positive 2.23, which is going to be greater than 1. So we can quickly check the piecewise function and make sure that those two values are going to fit our restriction here. And then you can also substitute each of those values back into the original equation, and we're going to check, does the left side equal the right side? So I'm going to begin with the positive square root of 5. I'm going to substitute it into the place of x to get this. And then when we go to simplify this, begin with the inside of the absolute value signs. When I square a square root, it cancels out, so I have just the value of 5. Combine those two like terms together to get a constant term of 3. And then when we take the absolute value of this, this will be a positive value. It is the same as what we get on the right-hand side. Then I'm going to take my second solution, negative the square root of 5. I'm going to substitute it in the place of x. So we can see here when we square a negative, that's going to become positive. And again, the squared is going to cancel the square root. Combine those like terms, 5 minus 2 is positive 3. And when we take the absolute value of this piece here, this is a positive value, so it is going to work out to be the same thing on the left and the right. So both of those solutions are verified. And if this algebraic verification is looking a little daunting to you, remember that you can verify in your calculator. We would go negative the square root of 5 and then store it as the variable, hit enter, and then you're going to enter exactly what you see on the left side of the original equation, and then enter exactly what you see on the right side, and just check to make sure that those two values are the same. And now we have to solve for the second case. So we're going to take the opposite of this absolute value piece. So I'm going to just take that negative and distribute it into the bracket, thereby flipping all of those signs here. And because it's a quadratic, I want to move everything to the side where the squared term is positive. So in this case, we're going to move everything over to the right. I'm going to add 1x to bring this to 0 x's, and I'm going to add 1x here to get 2x. So we're going to move everything over so it's equal to 0. And now I would check, can we factor this first? It will be easier than trying to use the quadratic formula. Are there two numbers that multiply to 1 and add to 2? And thankfully there are, so we can go ahead and factor that. So we're going to get one solution because for each of these brackets, our solution is going to be negative 1. And again, we now need to check this. So this is the negative case. So go over here to the piecewise function, look at the negative case. X has to be greater than negative 2, less than positive 1. So negative 1 is going to be about there. That is going to fit the restriction for that negative piece of that function. We can also algebraically substitute that in, again, to the original equation. So we're going to put negative 1 in the place of all of those x's, and then we're going to go through and check, does the left side equal the right side? So in this particular equation, we have 3 solutions. Make sure that you verify all of them.